These are probability notes 13, other normal distributions. Today what we're going to take a look at is we're going to look at data that can fit a normal bell curve. So we're going to look at data that's modeled using a bell curve, and we're going to find probabilities of different data values that would appear on this bell curve. For example, the mean height of an adult male is 70 inches tall with a standard deviation of 3 inches. Now, heights of adult males are approximately normally distributed, which means that they fit this bell curve like this. Let's find the proportion of adult males that are taller than 6 feet tall. And since we're working with inches for our mean and standard deviation, let's convert 6 feet to inches by multiplying by 12. That's equal to 72 inches. The first thing we're going to do is we're going to label the graph at the right. Now the mean is located at the center of the bell curve. That's this vertical line right here, and this is your mean or your average height. We're going to label that as 70 inches. Each tick mark represents a standard deviation. So if a standard deviation is 3 inches, that means this first tick mark is 3 inches further away from 70. So it would be at 73 inches. And each corresponding tick mark would be 3 inches from the previous one. So we continue to add 3. Going the other direction, we would subtract 3, which would get us 67 inches. Minus 3 is 64. Minus 3 is 61. Each of these tick marks is 3 inches from the previous tick mark, which represents one standard deviation. So each tick mark is a standard deviation, which represents 3 inches. We're next going to draw a vertical line where a 6 foot tall male is located. Now we've said 6 foot tall is the same thing as 72 inches. And what we're going to do is we're going to draw a vertical line at 72 inches, about here, a little further than halfway between 72 and 73. And we're going to shade in the direction that would represent males taller than 6 feet, because that's what we're trying to find, the proportion of men that are in this region of our graph. So we're going to shade kind of in the greater than direction. Now I'm curious to figure out what fraction of this graph has been shaded in. You may remember from previous class that the area underneath this curve and above this line is 1, or 100%. So we've shaded in a little less than 100% of this graph, or actually a little less than half of this graph. To find this probability, we need to know exactly how many tick marks away this value is right here. It's not quite 1 tick mark. How far away is this? To find this value, we need to calculate z, which is known as the standardized score, or the z-score. We can find this value by using the formula z equals x minus m over s, where m is the mean or average, s is your standard deviation, x is the variable we're working with in the problem, and z is the standardized score. We're going to use this formula to find the z-score for a 6 foot tall man, and here's how it's going to work. Z is equal to, this is our variable, in this case we're looking at 6 feet tall. 6 feet tall is 72 inches, so that's our variable, our changing value here. M is the mean, we said the mean is 70 inches, the value in the middle of the bell curve. And the standard deviation on the bottom is 3. So what we're going to do is we're going to crunch this out. Now you could do this in your head, I think. You could do 72 minus 70 is 2 divided by 3. And then typically we round this number to the nearest hundredth. 2/3 is 0.6 repeating. We're not going to write it as 0.6 repeating. We're going to round it to the hundredths place, which would be 0.67. It rounds up. Now, if you're using your calculator, just a warning, when you type this in your calculator, what you want to do is you want to actually type in the numerator 72 minus 70 in parentheses before dividing by 3. This will get you 0.6 repeating, which we round to the hundredths place. If you forget the parentheses, what you'll get is 72 minus 70 divided by 3 equals 48.6 repeating. When you type it in this way, the calculator is doing order of operations. It's doing 70 divided by 3 first before the subtraction, which is why it's getting the answer like that. We want the 0.67 number, which you get by putting parentheses in right here. Now we're going to label this location on a standard normal bell curve, and I'm going to scroll down a little bit here so you can see our new bell curve. These represent tick marks. You can think of this as being 0 tick marks from the mean. This is the mean right here, 0. And then we've gone 1, 2, 3 tick marks in the positive side, -1, -2, -3 tick marks away. 0.67 is between 0 and 1. Obviously, it's a little bit closer to 1 than it is 0. So here's where 0.67 is located at, and we're looking for this region here. Once we find this standardized score, we can use our tables that we used the other day to figure out what percent of the graph has been shaded in here. So I'm going to bring in my table over here. And if we look up 0.67, here's 0.6. We go across to the hundredths place. There's a 7. So 0.67. That corresponds with 0.7486. Now 0.7486 is this region right here. That's the area to the left of this line. That's not what we want. We want the area that's to the right of this line. So we need to subtract this value from 1 to figure out the amount that's on the right side of this line, the shaded region. And when you take 1 minus 0.7486, you get 0.2514. That's the answer we want. That's the region that's over here. Now, if there was 100 men at the supermarket, approximately how many of them would be taller than 6 feet tall? Well, 25.14% of them. So you can multiply 100 times this value and get your solution. And your answer should be approximately 25.14 of them. Let's look at another example. Here, the average length of popular songs on YouTube is 192 seconds with a standard deviation of 25 seconds. Assume that the distribution of these songs is approximately normal, which means that song lengths could fit on a bell curve. Most songs are around 192 seconds. You have fewer songs that are bigger and fewer songs that are smaller than 192 seconds. What proportion of songs are shorter than 3 minutes long? Now again, we're going to multiply 3 by 60 to convert 3 minutes into seconds, and that's going to be 180 seconds altogether here. Now, if you were answering this question, here are 5 steps I want to see in your homework and test for when you do problems like this. The first step I want you to do is write what the problem is asking for in symbols. This problem is looking for the proportion of songs shorter than 3 minutes long, so we're looking for the probability that our song length x is less than 180 seconds. I'm going to use the same units that we use for the mean or the average and the standard deviation. Second step is we're going to find the standardized score, this z-score, by substituting into the z equals x minus m over s formula. Here, this number that we wrote down here will always kind of be in the first position. The 192 is your mean. This is also the average that was quoted here in the problem, 192 seconds. Standard deviation goes on the bottom, that's 25. And when you crunch this out, you get negative 0.48. We can again verify this on your calculator. Just make sure that when you type this in your calculator, you put the numerator in parentheses. In our next step, what we're going to do is we're going to rewrite the problem based on this z value. So instead of finding the probability that x is less than 180 seconds, we're going to use a value that would appear on this bell curve, a z-score that's less than negative 0.48. So we're replacing the x with this z, and we're replacing the 180 with this negative 0.48. We can find this probability using our tables. So we bring our tables in here, and the probability that z is less than negative 0.48. If we go to negative 0.4 and across to 8 is 0.3156. We get that from our chart. And then we can sketch a normal curve showing appropriate shading. So I'm going to go to negative 0.48, that's this value right here. And we're shading to the left because it's a less than problem, and this region that's shaded in here is 0.3156. What I'd like you to do is I'd like you to find the proportion of songs that are less than 2 minutes and 30 seconds. You probably want to start by converting this to seconds first, and then solve using these 5 steps. Pause the video, let's see what you come up with, and we'll check your answer in just a moment. To find the proportion of songs that are less than 2 minutes and 30 seconds long, what we're going to do is we're going to convert 2 minutes and 30 seconds into just flat out seconds. So we're going to multiply 2 times 60. 2 minutes times 60 seconds is 120 seconds, plus the extra 30 seconds is 150 seconds. So 2 minutes and 30 seconds is the same as 150 seconds. In our first step, we write the problem in symbols. This would be the probability that x is less than 150 seconds, because we're looking for the proportion of songs that are less than 150 seconds. In our second step, we find z by substituting into the formula. Remember, it's always this number, this 150, here in this case that we're going to use first. The mean is still 192 seconds. That's the average. We're still dividing by 25, which is the standard deviation. And when you crunch this out, you get negative 1.68. On your calculator, don't forget when you type this in your calculator, you do want to put parentheses around your numerator. So 150 minus 192 in parentheses, and then divide that by 25. In our next step, we're going to rewrite the problem using this z and this value. Instead of saying x is less than 150, we're going to turn it into a standardized value on a bell curve. So we're looking for the probability on the bell curve that we're less than 1.68 tick marks, or less than negative 1.68 tick marks from the mean. To find this value, we're going to bring in our table here. Z is less than negative 1.68. Here's negative 1.6. We go across to 0.8. It's 0.0465, which is this value right here. So there's our answer, 0.0465. We draw our bell curve like this. Means in the middle. We should be going about 3 tick marks on each side. Negative 1.68 is between negative 1 and negative 2 tick marks from the mean. It's a less than problem, so we're shading to the left. We're looking at this region, which should be a pretty small region on your graph. It does correspond with the 0.0465 value we got, about 4.65%, so it shouldn't be much of the graph. For the last problem, it's a little more of a challenge problem. We're looking for the proportion of songs that are between 3 and 4 minutes long. See if you can set up the correct inequality for step 1 and solve it out. Pause the video if you need to. We'll take a look at your answer for this in just a moment as well. First step again for this problem is we're going to convert minutes to seconds. So we're going to multiply 3 times 60, and we're also going to multiply 4 times 60. If you do 3 times 60, you get 180 seconds, and if you multiply 4 times 60, you get 240 seconds. We're going to keep everything in terms of seconds. So in this problem, we're looking for the probability that our songs are between 180 and 240. To write our inequality, we're going to put x in the middle, and we're going to do these less than signs in between here. Now, if you do less than or equal to, that's fine. It will result in the same answer. For our next step, we actually have 2 z values we need to calculate. We're going to calculate z values for 180 and 240. So there's 2 formulas we're going to work out. We're using the same mean, 192, and the same standard deviation that we used in the previous problem. When you calculate out these 2 z values, again, don't forget we want to put the numerators in parentheses. The 2 z values you get, one's positive and one's negative. The negative value is negative 0.48, and the positive value is 1.92. As we move into step 3, we're replacing the x with a z, and we're replacing the 2 values that we got, the 180 and the 240, with negative 0.48 and 1.92. Now, if you want to, you can actually do step 5 before you do step 4, which would be taking a look at your bell curve. Now we're going to do our 3 tick marks on each side. We're looking at this region between negative 0.48, which would be here, and 1.92, which is almost at this 2 mark right here. And we're looking at the region that's in between here, so I'm going to shade in that region here in just a moment. I would say that this should be roughly about 50% of the graph. Looks like we've shaded in about half of the graph. Let's see if that's true. To find this type of probability, you may recall we look up each of these probabilities on your table and we subtract them. So I'm going to look up 1.92 on the tables, and the value that corresponds with 1.92 is 0.9726. Now what we're going to do is we're going to take 0.9726 and we're going to subtract it from the probability listed from negative 0.48, and that probability is 0.3156, it looks like. So we're going to use 0.3156 as a probability for this negative 0.48 value. And when you subtract these two numbers, you get a probability of 0.6570. It's a little over 50%, which seems to match our graph, and that's how you solve that problem.